Today we have the one of the fundamental of chemistry, and that is the atomic orbitals. Atomic orbitals are mainly responsible for any of the aspect of the material. And what are the atomic orbitals? And those are related with the electron distribution. So electrons, the subparticle of atom, and having the negatively charged, that is 1.6 into 10 raised to power minus 19 coulomb, and the negative charge magnitude is there. Charge, that is coulomb. And oppositely of electron is the protons, where the difference of magnitude. So in case of the proton, the positive magnitude as compared with the electrons. Electrons having the negatively charge. Atomic orbitals, how the dimension, the shape, the size. What is that? If we have any of the material, we have the specific size. The size of a particle, round, spherical. What is the size? And where is the material is where in the space? On Earth, different materials. For example, here the electronic gadgets. So where are those? Where is the space where the electronic gadgets are there? In air, on Earth, and space. That is the thing. So here, where are the electrons present? Why electrons are responsible for the this ordered planet? Number of compound, number of materials, whatever. If suppose any of the space research, you can say the spacecraft, the food technology, various foods. So atomic orbital. Atomic orbital, what is the space orbit? If suppose we can say the solar system, where the orbits are there. Specific orbit. Moon. Moon around the Earth. So a specific orbit of the moon is there. A specific orbit of Earth and solar system is there. So different planets. So where is the position of Earth? Anyone? If sun surrounds the continuously moving the Earth, and that is moved with the 24 hours a day and night, but continuously revolve. So the same thing is here in case of the electrons. Electrons will be also continuously move. So where is the electron in space? Where is the electron in a metal of their atom in a compound? They combined with the bonds. So copper, the metal. Where is the electron present in copper? And which electron? And how many electrons are there in copper? 29. So here one electron is there, 4s1. So we can say the electronic configuration that also come with the orbitals, atomic orbitals. Before going to that, atomic structure: proton, neutron, electrons, quantity. Then the quantum number. All of you can know about the quantum numbers. It specifies the shell, subcell, and atomic orbital. So, which quantum number is responsible for the atomic orbitals? That is, we will see principal quantum number, azimuthal quantum number, magnetic quantum number. So, magnetic quantum number is responsible for the atomic orbital. Which type of orbitals? Px, Py, Pz, dx, y, d. yz, dzx, dx square minus. Which one? S atomic orbital, spherical. P atomic orbital, tumble shape. D atomic orbital, four lobes are there. Where? X, I, Z. Axis, axial dimension. Very specific. But the question is there whether the electron continuously move. But where are those? Any space is there, location is there? No location. Continuously move. So that is the very because of that. So but which one is the orbital? Orbit? No. Orbital of atom. So that is the space. And that space having dimension. Uh, Then the shape of atomic orbital. S spherical. P for the tumble shape. Now that D for four of the lobes, then F are also there. Very specific arrangement of electrons. Okay. Continuously. So where are those? In space, continuously move. Like a Earth, like a moon continuously around the Earth. So a specific period continuously. So here atomic orbitals are where the maximum probability of finding electron is there. Where we can say that the electrons may be in this region, not fixed. Heisenberg's principle. So electrons. So that is the atomic orbitals are the space where electrons are present, but that is in the probability. Maximum probability of finding electron, and that space is called the atomic orbital. And this atomic orbital is especially and at two two elements combined with each other and formation of the linkage, the bonding linkage. So how they survive? For example, linkage between the earth and moon, the bonding, continuously bonding. Whereas so many celestial activities are there, but the bonding between the moon and earth and the earth with the sun. So similarly, therefore, here in case of the atom, they combine with each other and formation of the bonding. So those are the atomic orbitals with the electrons from one atom to another atom form different types of ionic, covalent, and coordinate bondings are there. So definitely we have the great role of the atomic orbital. So first of all, we can say, and here the orbital diagram. Orbital is a box grouped by sub-level containing arrows to represent. However, on we are giving in the, for example, in board, we can write in the box and then represent it with the electrons in the form of arrow. So atomic orbital, here various atomic orbital. For example, if suppose we have the 18 of first 18 elements and respective their electronic configuration, so which atomic orbital is there. So you can see and classify in the periodic table first of atoms. So here, if suppose the atomic number 1, atomic number 2, atomic number 3, atomic number 4. So that is the electronic arrangement. In atomic number 1, only one electron is there. So atomic orbital is the 1s atomic orbital. In case of the example is the hydrogen. The helium atomic number 2. So here two electrons are there, and where they present the space, there the atomic orbital. Maximum probability of finding of two electrons in the helium. So we have to continuously, when we have the carbon, then the nitrogen, oxygen, the fluorine, the neon. Neon having the 8 electrons. So two, whatever that is the inert gas configuration. So let's we have hydrogen, helium, lithium, beryllium, boron, carbon. 6. 7 atomic number, nitrogen, 8 is the oxygen, 9 is the fluorine, and 10 is the neon. So these arrange up to 10. So where, so where are the electrons? They are in a specified area, and that specified area is the atomic orbital. So this is the here one most important also concern about the valence electron. So valence electron, that is the outermost electron. There, so the role of valence electron is most important concern, because that is present in the outermost electron. That is the security of that particular atom. So valence electron, outermost principal energy level of an atom, that is also the core electron, that is the inside. So security with the outer electron. Outermost electrons are the valence electron, and inside the core electrons, inner electrons. So in, for example, the nitrogen. In case of the nitrogen, 7 electrons are there. Electronic configuration of nitrogen, nitrogen 7, 1s2, 2s2, okay, then uh, the 2p3. So 4 plus 3, that is the 7. So now the 7 electrons are there in nitrogen. So outermost electron, where the 7 electrons there in nitrogen atom, where are those? This one is the whatever we can say 1s2, 2s2, 2p3. Total 7 electrons in nitrogen. 7 electrons are different from each other also. It is the quantum. So the magnetic quantum number provides the specific atomic orbital. So here core electrons in nitrogen 7. What are those? The inner electrons. And valence electrons, outermost electron, highest number. So 5 electrons are there, but which we have the valency of nitrogen is 3. So here in outer shell, 2 plus 3, 5 electrons remain. 4 electrons, two elements that will the same valence electron arrangement show very similar chemistry. This is the periodicity. The after appearance of that, so those are arranged in a group. Carbon group. Carbon below that is the silicon. So that is the behavior is the same. Most one halogens. Halogens having the valence electron, outermost electron, 7, but one is responsible for the, so that is outermost electron, the highest. So here one halogen can take one electron and form a bond. So where in case of the example is the fluorine nitro 9 atomic number, 1s2, 2s2, 2p, 5. So outer shell electrons, the 5 plus 2, 7. So then they form a bonding respectively that can be shared. Now, this one we discuss electron location, where is the electron is present, and then where is the energy. Because continuously moving that needs the energy. If anyone continues, if suppose we move continuously, so definitely we require the energy, and that electrons having the different energy levels. So first energy level, the principal energy level. Then it corresponds to the row on the periodic table. So as n increases, energy increases and the electron is farther away from the nucleus. So whatever that, the energy is responsible. So where will be the electron from the nucleus? That is, we can see, and here the energy is also responsible. So electron will be there, and whatever we have see the space, and that is the atomic orbit. We can see the left and right, whatever we can here see the different shapes of the atomic orbit. One, two, three, and four. F different shapes. So here Y the dumbbell shape, and the P the four lobes, and then we have the four F. So 3D, 4F, why these are followed by the Hubble principle, how two electrons are filled, no availability of 2D, 3D, no availability of 3F, why. So that is relevant with the different aspects of the atomic theories, atomic concern, even. So here the shape of the atomic, how the shape is formed. So that is the arrangement, that is the moving of electron continuously, having the maximum probability of finding, and that area is the orbital. So here if 4f electrons are there, so there may be like a designed a dimension, simple, spherical, like spherical. That is the S. So 1s, 2p, 3s. These are the, in case of so this one is most relevant. So now we can say atomic orbital, different shapes, 1p, 2p, 3p, 3d, 4f. Now these are the some of the bonding, what how the bonds are formed, the overlapping or mixing of two atomic orbital. This is also that gives the bonding between the two or more atoms. So now you can say here and here, and yeah, we will back to the above principle, how these electrons are filled. So here the K, L, M, and these are the period number. One period number, two period number, whatever the K, L, M, N, O, P. That was the given by the atom structure in which Bohr has given K two electrons. So which where go the one S1? Why 1p is not there? Because that is not possible in that. 2l 8 electrons can accommodate. 3 third m 18 electrons can accommodate. In case of the fourth, 32 electrons, and in case of the 50, in the fifth cell. Fifth cell we having the 4f, 5f. So that's we can say that 50 uh, so what is there? The specific, this is the Hubble principle, whatever how to uh, uh, get the answer. Here, the 1s, 2p, yes, these are the shape of the atomic orbital. We have already discussed the different things 2px, 2py, 2pz, three atomic. In case of the 3D, 3dxy, 3dy z and 3z x 3d x square minus y square and 3d z square. So those five atomic orbitals are present in 3D subcell. P subcell, the three different atomic orbitals, px, py, and pz. In case of the 1s, 2s, 3s, 4s. So those are also the part of the very specific design of atomic bomb. And because of that specific design, and then bonding will be there. So whether the bonds are ionic, covalent, or coordinate compounds. So this is all. These are the pictures of a very specific design, whatever the shape, whatever the atomic orbitals. Now let's here. This is also important aspect, and that is the bonding, overlapping. S S or PP or the two types of sigma bond and pi bond, how they are formed. The PX, PY, PZ. So PP, one of the electron from one atom and one of the electron from the another atom. So that is the sigma bonding in between the P because of the PP overlapping. And also the sigma is also concerned in the SS overlap. SS overlapping simple, whatever that is the simple one, spherical. But overlapping in different p atomic orbitals, if suppose we have the px, pz and combined with another elements pz, for example, in case of the chlorine. So chlorine having the chlorine-chlorine bond, that is of the sigma bond. So PP type of overlapping is there. In case of the pi, there is also the PP. So one more thing is this is the order how the electrons can be filled. So 1s, 2 electrons can accommodate 2s, 4. So up to whatever, if we have to go back to the 4f, then 70 elements are included. 3p only 18. So now we can get that such informations are very essential for the chemical bonding. Now, here are the some of the pictures, electron distribution. So all of you can see the different pictures, special pictures are there. What are those? Here the special picture of atomic orbital. Spherical S1, P dumbbell shape, Px, Py, Z. Three dimensions. So where X, where the Y dimension, the Z, X, Y, Z. So similar, they follow the rules of the X, Y, Z. And here Px means the X. Then X angle, X dimension, Py for the Y dimension. Similarly, so Px, Py, Pz, these four are distributed. And definitely. So in case of the d atomic orbitals, those are 5 n. So what are those? Even in the d atomic, the naming of those d atomic orbitals. So px, py, pz, and then dxy, uh, dyz. Second, d atomic orbital. Third atomic orbital is the fourth. Is the uh, dxy, dyz, and dzx. And then fourth and fifth. So those are the dx square minus y square and the last one. So here we can say the different arrangement of the orbitals. D z square also. So 5 d atomic orbitals, 3 p atomic orbitals, and 1 is the one. So we can back to the quantum number principle, that is the shell number. 1s2, the principal quantum number is 1. 3s2, the principal quantum number is 2. So 1s2, 2s2, and 3s. So we can say the shape is the S, spherical. That is the S atomic, but that is the continuously uh, goes the size of that particular is bigger. So that is also concerned here the shape of the atomic orbital, and these atomic orbitals defines the well-known shape. P atomic orbital, the shape. D atomic orbital, shape. F atomic orbital, the shape. So this one is the important answer. Now the next slide. So we have to continue. For that, here the S and P type of symptom. Here you can say one more thing is there. What are the our planet moves around the, so here sub levels are also important, assisting that spin, and most one is the spin one. Electrons in the same orbital must have the opposite spin. One spin clockwise and other spin is the counterclockwise. So plus half and plus minus half can be represented in this case. So next slide, whatever the we can say, uh, these are the sublevels. So electron location, that is the atomic orbital. Then we have the sublevel shape of electron cloud. S is the spherical. P dump bell. So this one, whatever mentioned, sublevel shape of electron cloud, that is the spherical in case of the S atomic orbital. And then we see the P dumb, dumb bell, two complex. T stand for the two. F also the two complex. Then first energy level has one of the S, one of the sub level. Second energy level is the two sublevels S and P, whatever we have already discussed in the periodic table. So that have the specified the S, the P, and the T. So here the levels where subcell, and then further we have the other sublevels. Sublevels. The third energy level has the three sublevel. This type of fourth energy level is the four sublevel. What are those? S, P, D, and F. So this one spherical dumbbell shape, two complex. This can be here also. uh, One of the where you can see the spherical, that is that in the red color, the spherical shape orbital, spherical shape of the orbital in case of the red color. Then we have the yellow and orange. So those are the blue one, the dx atomic orbital. The green one, green, the f atomic. There are the seven in number in case of the f. So if suppose we have the two electrons in seven, so there will be the 14 electrons. This one is the, so now electron configuration. This is important, relevant with the electron configuration. The three rules that dictate how electrons are arranged. Above principle, all of you have well known. The electrons enter orbitals of the lowest energy first. Pauli exclusion principle, atomic orbital can hold atomic orbital can hold a maximum of two electrons. This is also the important aspect of the electroanalytics. Electroanalytics. So here the different rules and regulation. Pauli exclusion atomic orbital can hold two electrons, and those two electrons must have the opposite spin. So that will be the definitely formation of the bonds. Now, the Hund's rule, when electrons occupy orbital of equal energy, same energy, then one electron enters each orbital with parallel spin. So this is also very good question. So now we can say uh, here the Hund's rule, the Pauli exclusion principle, the Hubble principle, how electrons are built. So great values of the energy level, and that is the designed atomic orbital. Px atomic orbital, y and pz. So that is how electrons are filled in different atomic orbitals. So atomic orbital, we can say uh, this is also responsible for the formation of the bonds. Ionic bond, one thing. So we can say ionic bonds are because of the electron transfer. So what are those electron transfer from one metal to another? Okay. Covalent bond because of the pairing of it. Coordination bond because of the like a covalent bond but coordination itself. Then the dative bonds are also. So when a single atom provides both electrons which are needed for completion of these two different types of bonding. So now here are the some of the explanation and different atomic orbitals, whatever those spherical, dumbbell shape, the lobes, uh, dx, dxy, dyz, dzx, dx square minus y square, and then dz square. So here are the some of the whatever the maximum number of so because of gas contain the atomic orbital. When what is the maximum number of electron found in each of the following? So how this can be explained? So how many electrons are there in 2p orbital? One thing. How many electrons are there in 2p subcell in 2,4p sub level? So at 2p orbital. 2p orbital means the 2px and 2py and 2pz. So how many electron can accommodate 2pz or 2py or 2px? So that can be explained. The maximum number of electrons are found in that particular area. So if two electrons are found in the space in the area, those are the atomic orbitals. So 2px having the two electrons can accommodate. The sublevel, so 2p sublevel, how many atomic orbitals? In case of the 2p sublevel. However, earlier discussed about the shells, the subcell, the atomic number, the spin quantum number, spin of that. So all those fundamental are responsible for that. So 2p atomic orbital, 2px, 2 electron, 2py, 2 2pz, 2 electrons. And in case of the sublevel that indicates whatever the sub level means subcell, shell, subshell. The third layer is the atomic. Fourth layer is also important, and that is related with the spinning of the electron. So here case of the 2p sublevel, 6 electron can accommodate 2px, 2, 2py, 2, 2pz, and in case of the 4p, the p atomic orbitals. What are those? The 6. Then 4p sublevel, also the 6 electron can be accommodated. So these are the queries where we can get the answer. Now, the 3D atomic orbitals. How many electrons can accommodate in 3D orbital? Here, the question is the orbital. So 3dx, 3dy, 3d, y. So these three at the atomic level, uh, atomic structure in which the 3D orbitals are 3dxy, 3 yz, 3zx. So 2 plus 2 plus 2 plus 2 is the electronic configuration, and last plus 1 is also. So 5 orbitals are there. So each atomic orbital can accommodate 2 electrons. So total 10 electron in a sub-level of the 3D. Any of the F sub-level, that is the related with the 52, and that can be answered. Now, these are the questions. What are those particular questions are there? Subcell, quantum, principal, azimuthal, magnetic, spin. So, in a subcell where n is equal to 6, so where it is in a periodic table, the sixth period, n is equal to 6, and one more is the azimuthal quantum number. So, anyone, all of you have well known about different quantum. Azimuthal quantum number represents with the L. So here subcell means 6, and L is 10, L is equal to 2, so that is the D. So 6D can accommodate how many? So that is the answer, because D subcell, and that produce the atomic orbital. So here the correct answer will be the maximum of 10 electrons. Now, another question. Consider the ground state of chromium atom. Chromium atom is the one of the specific electronic arrangement, specific electron behavior. So, ground state of chromium, the atomic number is 24. The number of electrons with the azimuthal quantum number. Here, the reverse back. So, L is, we have to find out first of the L. So, L is what was the azimuthal quantum number. L value is the 1. So, what will be there? The P sublevel. And if L is equal to 2, the D sublevel. So D sublevel and F sublevel. So where we can say the ground state of chromium, the number of electrons in the chromium. So L is equal to 1, that will be which one? The P. But what about that particular? So, and here in chromium having the configuration 1s2, 2s2, 2p6, and then 3s2, 4p, 1s2, 2 electron, 2s2, 2p6. So 10 electrons. Okay, then 12 electrons, the next third one, and finally the 36 electron. So here in case of the chromium, the configuration, whatever we can say, the argon, and then 3d5 and 4s1. So here 3d concerned with the 2 eligible to. So here how many electrons can accommodate in a chromium? Because 3d 5. So 5 is the answer for that. And in case of the L is equal to P, so there L is equal to 1. So what will be the answer? So here the electrons, because the correct answer the 5 and 12. Okay, so now we can say thanks for all. So whatever we have learned, the different aspects of the atomic orbital, different accommodation of the electrons, where the electrons are remain, and why. What is the role of the atomic orbital? Very specific role of atomic orbital is there. Why that particular specific role? Because they help in the bonding. What we have, we can say uh, the bonding between, this is for the bonding. Atomic orbitals for the bonding. Whether which type of bond is formed. Ionic bond, what happen in case of the ionic bond? The formation of ions. So when ions are formed, the simple example itself is the sodium chloride. So in case of sodium chloride, sodium cation is present and chlorine anion is present. So what happened from the sodium atom? So sodium atom, uh, why form the sodium cation? So anyone? So in case of the sodium, the electronic configuration up to the neon, and then three whatever that will be 3s1. So 3s1 having the spherical atomic orbit. So what happen? Where go that particular electron in the sodium positive? So that the space of the 3s atomic orbital of sodium is vacated. So how this can be vacated? Why the electron is transferred and easily transferred? Why the sodium form the sodium cation? So that particular the space. Okay, this particular space of electron is vacated in case of the sodium 11. So 11 electrons in sodium, whereas the 11th electron is present in 3s 1. So in sodium chloride, that is the solid, that is the ionic compound. So there is the in sodium one electron is removed. And what happened? So 3s atomic orbital is remained vacated. So where goes this? This 3s atomic orbital diluted. And in case of the chlorine, one more thing is there. In case of the chlorine, one electron came. So from sodium, electron goes to the chlorine. So that becomes the chloride ion. And in sodium, that remain as the sodium cation. So sodium chloride. So here the role of the atomic orbital is responsible. 3s atomic orbital of sodium, and then the uh, 3pz atomic orbital of chlorine and formation of the ionic compound. Whereas in case of the carbon, there the four electrons are there, and the configuration 1s2, 2s2, 2p2. So four electrons in the outermost electron. So the four, only four. So the carbon want for another hydrogen atom. So what happened in this particular case of the CH4, the atomic orbital from the carbon. So here the 2px and 2s, two different atomic orbitals, and here the concept given by the that is the chemical bonding, and that is the hybridization. So in case of the hybrid, another concept. So those are the mixing of all those particular electrons. So definitely you can say that particular bonding, coordinate bonding, how this coordinate the electron pair is transferred from one space. In case of the ammonia, the lone pair of electron is present. So therefore, the electronic, whatever, for this purpose, the atomic orbitals are responsible, and they are responsible. That is because of their special characteristics. So what are those particular specific characteristics of atomic number of those? Even the electron activity, even the electron affinity, even the ionization potential, even there the size also effective, nuclear charge. So many of the properties also correlates with the atomic orbitals. So anyone have the any of the difficulty, then he or she can ask me, and that is the most. Yes. Now the open. Anyone can ask me any of the question. Whatever those can be obtained from the mobile, from the email ID rc.chipa at the rate of mygyanvr.com. So this one is the all about what the atomic bomb, whatever those can be. Atomic bomb, most important aspect of most important aspect of the. So that is all about atomic orbitals. Yes.